Let's take a look at this example. This time we are going to have highs in following cells: 3, 5, 6, and I'm going to have don't care. DC stands for don't care in cell 0. We cannot make bigger groups than groups of 1, so we can not use K-map to solve or to simplify this expression. So what I'm going to do, I'm going to use Boolean algebra. I'm going to use don't care, and let's see how it's going to look like. I have A naught, B naught, C naught. This is the term which represents the position of my don't care in this cell. Or I have A naught, B, C. I have or A, B, C naught. Let's take a look what we can factorize from these terms. I have A naught and A naught. I can factorize A naught. And inside of the parentheses, I'm going to have B naught, C naught, or BC. Or I have from these two terms A, and inside of the parentheses, I'm going to have B naught C or BC naught. I have A naught. This is nothing else, just exclusive NOR. Or A exclusive or B, C. These two terms are complements. That's why I'm going to call this one Q, and this one I'm going to call Q naught. You can call this one also Q naught and this one Q, doesn't matter. So that's why I'm going to call this one Q and this one Q naught, just to make difference. And I have A naught Q or A Q naught. As you can see, this is nothing else, just the exclusive OR gates. I have A exclusive OR Q, where Q is equal B exclusive NOR C. That's why I'm going to write this as A exclusive OR B exclusive NOR C. Now we can implement this circuit, and we are going to have input A ORed with exclusive NOR gate. Okay, this is my exclusive NOR gate with inputs B and C, and this gate has to be exclusively ORed with A. That's why I'm going to draw over here exclusive OR gate. That's my output. So these are the solutions to my problem. Let's take a look at the next example. We have ones in cells 1, 2, 3, and 4. We have don't care conditions in cells 0 and cell 6. Next, we're supposed to keep in mind that we can make the groups for 3 variable Karnaugh map of 1 high or 2 highs or 4 highs or 8. Always remember that we're supposed to group many highs together with don't cares if we have don't cares, as possible. Take a look. We have two groups. This is one group, and this is the second group. Remember that K-map, right? It's going to behave like a piece of paper. You can fold the paper, and you will see that these two cells are going to be next to this one if you are going to fold it. So let's take a look at the first group. My first group is placed in 2 columns and 2 rows. At the side of these 2 rows, I have complements. We said that we are going to ignore complements. That's why I don't pay attention to the left side. And this group is placed in 2 columns. The common variable for these 2 columns is C0. That's why I'm going to write C0. I finished with this group. Let's take a look at this one. This group is placed in 1 row and 4 columns. We said that anytime we have group placed in 1 row, we're supposed to copy down everything, whatever is at the side of this row. I simply have A0. That's why I'm going to write or A0. Next, you're supposed to look up. Look up at these 4 columns. As you probably noticed, there is no any common variable for all these 4 columns because I have B0, B0, B. So B is different than B0. So anytime we have complements, we simply ignore them. We have C0, C. We have already complements. We ignore them. That's why we are going to simply ignore the top part for this group. My answer is simply C0, A0. Now let's implement this expression. We have 2 inputs. Input C connected to the inverter because I have bar, and input A connected to the inverter because I have again bar. Both of them are connected to the OR gate because I have plus sign. Okay, this is one of my answers. I can also implement this in different way. Let's see, this is my second answer. I can use simply negative OR gate with 2 inverters and inputs C and A. And I can have third drawing by using the Morgan's theorem. The Morgan's theorem says C0 or A0 is equivalent to C NAND A. So this is nothing else as the NAND gate with input C and A. So these are the solutions to my problem.